Today my topic is functional reactive bliss, or making modern apps with spreadsheet-like ease. Robustness, responsiveness, and ease. So the first question is, why is it so simple to use a spreadsheet like Excel compared to programming? In spreadsheet, the spreadsheet framework handles all the updates, calculates all the values, and updates the GUI automatically. The user only needs to declare the relationship between different cells by specifying functions in a functional way. When the user changes the input, the spreadsheet intelligently recalculates only those cells that need to be recalculated, and this is called the reactive way. So this is easy enough even for non-programmers. Now, NAPA has something a bit similar to this historically, NAPA dependency management. We have object up-to-date management, manager item up-to-date management, and table up-to-date management. And we know these all work very badly, unfortunately. They are limited in scope, they are complex and error-prone implementations, and they do not extend to the GUI. So let's compare Excel now to the real programming, so said. Print hello world. This is the first sign of a real programmer. We get this kind of image, you know, when you are going really low level and writing print hello world. Not for the Excel people. And this is called imperative programming. And it's opposite of what we do in Excel with the functions. Here we are saying to the computer, do this. We are ordering the computer to do thing, changing a state. For example, NAPA commands and NAPA macros are very often done in this kind of imperative way. They are changing the world based on my order. And they unfortunately kill this kind of reactive functional approach that we are used to in Excel. So the problems that we get when we are trying to manually update the GUI or manually update items with our code are many. So often the program doesn't know what should be actually updated and how to update it, which methods we should call to make those updates. In what order should we update those things? Sometimes it's very crucial that we do it in right order. We get many bugs when we don't do all the necessary updates and something is out of date. And we get slowness when we do too much updates and duplicate updates. So this leads to unhappy situation. And many NAPA bugs have been and are and will be, unfortunately, in this kind of updating logic. Often these bugs are challenging to fix and easily breaking again. And update hell is the end point of this. For example, in NAPA Manager framework, when we are changing value of a ref system VARDEF, that is very difficult. It's had many bugs, and all the bug fixes, which I have been doing, some have been leading to other bugs, and it seems like a dead end. And also, just a few days ago, we were fixing a problem in the ER main window by adding a 500 millisecond delay in one long macro that was magically fixing the update. Very challenging, very brittle. When you search the NAPA code base for the word update, there's thousands of matches, both in Fortran code, in NAPA Basic and C#. And this is only the tip of the iceberg, because of course we are updating things also in other code. So why cannot we use the Excel-like nice programming where everything is automatic? Well, there are limitations. First of all, the GUI is limited to a set of tables and graphs, not very flexible. The single cell values are limited to just single string or single number, not this kind of compound object values that we would need in big programs. And the input data can only be changed by the user manually changing the value of a cell and not in some kind of more UX interaction friendly way. But what if there would be technologies that would be functional and reactive, just like Excel, doing all the updates automatically, but without all these limitations? And that's what we are saying now. I call it the blissful combo. And this works with single-page web applications, which is the modern rage, in the web development. And here we use ClojureScript, which is a functional language that uses immutable data and atomic state. And we use Reagent framework that will do this kind of UI level update. The React comes from Facebook originally, and Reagent is a wrapper for that in ClojureScript. And this will handle all the GUI updates automatically in reactive functional way. And then we use Re-Frame framework, which is doing the reactive functional update for the whole of your application state. So then nothing is left for manual updates. There are some other alternative frameworks, getting a bit similar results, but not exactly the same. Some are based on ClojureScript, some with JavaScript, and some with Elm programming language. I will not go more into those, but you can see later. So how does it work in the Re-Frame? It works like how the water circulates in our ecosystem. There is first application state, which corresponds to the input cells that the user is modifying in Excel. And then there are queries which correspond to the calculated cells in the Excel. So we specify functions that are function of the application state and represent derived values. Then we write functions for views, which represent the GUI, and they use the queries as an input. And finally, there's the GUI state. This is actually the HTML page that you see and that the views represent. And then the other side of the flow comes for the user interaction. So the user is clicking something or changing some value, and we get events. And then we write functions that map those events into effects which are changing in a functional way the application state. And then we come back to the origin, and the next cycle can begin. And all these parts are written with pure functions, so there's no side effects, and the Re-Frame framework is actually doing all the motion between these. We are just declaring the mapping of these values to each other, but Re-Frame does all the update, and we don't need to see or care about that at all. And it is also doing it in the optimal way, recalculating only minimally those things that are needed and updating only those parts of the GUI that are needed very, very fast. So let's look at an example. Here's some form from application I've been developing for some company. And this is collecting information with a classical web form for some accounting reasons. And let's look at the code for that as an example. The application state here consists of different nested data structures with some company names, bank accounts, addresses, and so on. Then we have queries that are functions that are drawing data from the application state and creating higher level calculated values. For example, here the customer is being drawn from the database. Then we define views, which are functions that contain this kind of HTML-like code. So there's the table row, table data, table body, and so on. And this is constructing the HTML view, again drawing values from the queries. And this results in the generation of this form, depending that mapped from all the way from the application state. And then we have events, and we write the event handlers that will, again, are functions taking the application state and making modifications to that. So this is how it rotates around. And there's not a single line of update code in any of this application that will say, now put this value to this variable or this data point or this widget or something like that. Everything happens with Excel-like ease. Second example I've been doing earlier already is a board game. This is using SVG and bitmap graphics in the HTML. And you can interact either with the mouse or giving commands to play this game. And it's multiplayer synchronized game. And this has been published earlier in Scrolly magazine. If you want to read, there's an article about this in Finnish. But this was based on the functional but non-reactive version of this game. But now I have a new Re-Frame-based version, which I have a link here in GitHub that's open source. You can go and see this as an example. And this also uses the WebSocket communications and Google Cloud Data Store for the games. So additional benefits you get from this approach. So with the Re-Frame you get the reactive programming and functional programming combined. But you also get immutable data, meaning that your objects or data, they can never be in some intermediate state in the application state. You are moving in a definite step from previous state to the next state without something being messed up in between. With the ClojureScript, you get this kind of Lisp dialect with all the benefits that come from that. It's a dynamic language, so you can develop it in a very rapid way, no compilation needed. You can change any code at any time, and it's immediately effective in your debugging environment. You can see changes in less than a second. No classes at all. Everything's just data, and functions. With the Clojure, you can use the Clojure language both in the browser as ClojureScript, and you can use it on the server. And then you get the same language on both sides, which provides advantages. And because the back end is based on JVM, you get all the libraries and goodies that come with that. And this implements the GUI as data paradigm, where the GUI is a function of the state. Very neat. And with this, in the end, you can focus on the application itself. This kind of update logic and the bugs from that are not jumping in your face. And you can be so productive that you can get nice stuff done even on some hobby projects on your free time. And then you can be happy like this. And you can use it at home, and you can even think of ways of using it at work. Thank you.